So this is the problem we are looking at. I hope the screen is now visible. Market basket analysis using Her Majesty's ship Titanic. Okay, right. So the list of passengers on board Titanic that traveled from Southampton, UK to New York, USA in 1911 is given as an attachment. The ill-fated cruise liner could not finish its maiden voyage and sank in the middle of the Atlantic. The attached data set gives the list of passengers on board along with their age, gender, the passenger class that they traveled in, and survival status. Using rules of association, that is support, confidence, and lift, determine which cohort of passengers across age group, class traveled in, and gender had the greatest chance of survival. Use the data sheet to identify children, adults, and seniors. Seniors are those passengers who are about 50 years of age under different age groups. Ignore records when incomplete passenger details are available. So essentially, this is the historic data. Let me share that. Okay, I hope this is visible. The Titanic file is also visible, right? Please confirm.
Yes, sir. This was
okay. So now we have the names of passengers on board the ship. Then, in what class they traveled, first class, second class, or third class. You have their ages in years. You have their gender specified and whether they survived the ordeal or not. Okay, so we will be using this data to do a market basket analysis. Okay, so the first thing that question is asking you to do is use the data sheet to identify children, adults, and seniors. That is, seniors are passengers above 50 years of age. And it's also saying ignore records when incomplete passenger details are available. So how do we proceed? Let me just put the question to all of you. How do we proceed? Because we've got a raw data here, we need to clean it up, first of all.
So we need to delete the missing values.
Delete the missing values. Great. Okay. So first thing is we'll have to get rid of all the missing values. Yes. So after that, how are we going to determine the whatever children and adult and senior, that classification?
According to age.
Okay, according to age, but like how do we actually do it on Excel?
Nested if statement.
Nested if statement. Okay. All right. Okay, let's attempt doing that then. Okay. So I think yeah. So fine. Let's try that. The first thing we'd like to do is remove stuff we don't want. So let me just convert it to a table initially. Control A, and I complete to Control T. Okay, my table has headers. Okay, and let me try to see blanks. Okay, let's do one thing. I'm inserting and I'm trying to count that. Count blank. Control Shift down. Zero. Okay, there is no problem there. Let me drag the formula here. There are 119 blanks because we don't have information about the ages. Okay. Dragging it further. Okay, there is no problem there. There's no problem there. Okay, so essentially the missing data we have is with respect to age. So not all the ages are marked. So there are total records is 1315. Let's be sure it's okay. It's counting all the way till 1315. I don't know. It's only counting till here. So let me correct that. Blank. This control shift down. Okay.
I have one missing value for column B. Okay, yes.
One missing value for column B. Okay, let's see. Okay, there are 557 missing values for age and one missing for column A. Okay, so let us then delete those. Okay, how do we delete it? Let me arrange this in ascending order. The age, because I suppose data control shift sort by age, largest to smallest. Let's say okay, and let's say yeah, right from some point we don't have data, so we need to find where it is. Right, okay, so right from this point downwards, control shift down, and I'm just deleting that data because that's of not much use to us.
So we can probably just filter out and then delete those rows.
Yeah, maybe either way, whichever way. So all I'm trying to do is remove data. Okay. So now we have a problem on hand. So now it is counting 557 errors here. So I will just try to convert it back to from a table. I don't want it to be a table anymore. I'll try to convert it back to a range. Yes. Okay. And now let me just blank. Control shift down all the way. Okay. And okay. Fine, 0 everywhere. Okay. So all I've done is cleaned up the data. Okay. I've searched for blanks in the data set and I've eliminated records which had blanks. That's what I've done. Now there are 0 blanks. I hope you followed it. Okay, no issues, huh? No, okay, just give me a thumbs up if you understood what I did. Okay. Fine, yeah, okay, almost sure. Ravi is not sure. Ravi, are you okay?
Yes, sir, I'm fine.
Okay, great. Okay, so all that I did is removed those records which do not have complete data. Okay, let's move ahead. Fine. The next thing which I need to do is identify whether the customer traveled by first class, second class, or third class. Okay, so let us insert some columns there. Okay, so I want to determine whether he traveled by first class or second class or third class. Okay. Now I can use a nested if, as I think Deepak had suggested. So what I do is, like say, I'll put first here. If this is equal to, it's equal to this. Okay, then put 1 here, else put 0. And I need first this C1 to be locked, and I use F1, close it, and I drag it down. copy the formula down. Okay, similarly, if I want to know if he's traveled by second class, all I need to do is copy this formula, Control C, Control V, and see, I need to drag this here, and it's locked, and this should be here, and I've rectified the formula. So basically, essentially, it is checking if B3 is equal to D1, and if it is correct, it gives 1, else it gives 0. And I drag the formula down. Okay, so which means there's a problem here. This should have been 1. If second is equal to second, 1 and 0. Why is it not picking? So Control C, Control V, values. Okay. Okay, second. Okay. So third, Control C, Control V, and I'm just copying this formula, Control C to Control V, and I'm just checking, ensuring that cells point to the correct references point to the correct cells. Okay, cell referencing 0. Okay. Okay, third, fine. Okay, so I've got first classification of data. I know how they've traveled, each of those passengers. Okay, I've just used a formula and just tried to see. I hope it's a simple exercise. I hope we are all following. I hope there's no issue with this. Okay, all right, yeah. So now let's move on and get the data. We need to understand age. Okay, again, insert. Okay, 3, and I'm saying we need children, we need adults, and we need seniors. Okay. So children are between less than or equal to 18. So that will be like less than equal to 18. Seniors are above 50. That is greater than 50. Okay, so let's check that here. It's equal to if this value age is greater than or equal to, is less than or equal to, less than or equal to 18. Okay, I think, okay, that's an issue. I should have put in some place 18. So if age less than or equal to 18, then it is child, else not a child. Okay, I'll drag the formula down. So let me see, look for the first instance. Okay, it should come somewhere at the bottom because we have sorted it based on age. Okay, so it's not working. It is giving me 0 here. Let me see what's going wrong. Children. If F3 is less than 18, okay, I didn't lock this. Okay, locking. down. Let me copy this down. Let's check. Okay, that's fine. Okay, it's giving a 1 the moment it is less than 18. Yeah, 18 or less. Okay, 1. Everything else is 0. Fine. Okay, above 60, above 50 seniors. So again, is equal to if I can just copy this formula from here. Control C, Control V. It is copying. I have to fix the cells correctly. Okay, not if F3 is greater than 50. Greater than 50. It's 1 and it is 0. Okay. Okay. So I should just put it as 50. Okay, if F3 greater than that figure, 1, 0, 5. Back it down. Okay, so the moment it is less than 50, it is dropping to 0. Okay. Does it say strictly greater than 50 or does it say greater than or equal to 50? Let me just look at the question. Above 50 years of age. Okay, fine. So we'll go with strictly less, above 50. Okay, fine. So how do we propose we do the third one?
So with or statement.
Or statement? Is it or statement or with
and statement?
It is with and statement, exactly, because it has to see. It's easy. Something is less than, it's easy to determine that. Something greater than, it's easy to determine that. But when we have something like in between, we need to have both the criteria satisfied. That is, it should be above that and less than something. Okay, so we'll use the and statement. Okay, adults would be, let's say, so if, and let's say let's have a test and logical test is this greater than 18. Okay, close it. G. Logical 2, that is F3 less than 50. Less than or equal to 50. Then 1, else 0. Okay. Let me copy this down. Okay, I need to fix the cell referencing. Cell referencing G1 has to be fixed. F4. This should also be fixed. I1. Copying that downwards. And no, it's not turning. Something wrong with the formula. Let's try.
Sir, I think I41, why this?
What is that? Sorry. Yeah, because there are two conditions we are checking. First is if F3 is greater than G1, that is if the person is above 18. Second is F3 should also be less than 50. I41. Acha, I41 is not locked. Oh, sorry.
Yes, that's mentioning function F4. You press F4 is pressed.
Fine. Okay. And
Will if S will work here in this case?
if else will work, Sujendra, any which way, any logical thing which will satisfy these two conditions. 1 second, let me just see whether it's picking up the right value, but this should pick up. It should pick up 22. It's not picking up 1. 1 second. Okay, 1 second. So essentially what this formula is trying to do is the AND statement gives me 1 if both these conditions are true. Okay, the two conditions I'm trying to check is, that is, first statement is if F3 is greater than G1, that is if 71 is greater than 80. That's the first criteria. If that is true, and second criteria, that is your F3 is less than I41, that is the value 50, then I need a 1, else I need a 0. If both these conditions are satisfied, I need a 1, else I need a 0. So that is what I'm trying to tell Excel to do. But somewhere there is an issue. I don't understand why it is not picking. It should have been 1 here. Okay. So Sujendra, you're suggesting if else if, is it?
If S.
Sorry, else if?
If S.
If S, is it? Ifs.
Yeah.
Sir, if with and condition works for my spreadsheet, so it should work. I mean,
Absolutely, that's what it should work. I don't know why.
yeah, but if I mean that's also an option. There are multiple ways.
Let me try ifs. If logical test. Value true, value false. Okay. Let me try that again. It's equal to if logical test and. Okay, first logical test is your 71 should be greater than 18. Let me lock that.
Sir, should it be greater than equal to 18? Because at 18, a person is considered an adult. So should we equate it here or I mean, should we consider exact 18 as children or as adult?
Okay, there we have considered less than or equal to. So that's the reason I'm going with the opposite of that. The children we looked at less than or equal to. But okay, it's a simple thing. If you can just go with less than, strictly less than means you have to go with greater than or equal to here. Just a minute. Let me just try to get this correct. And this should be less than or equal to this value here. And let me lock it. And then I say value if true is 1, value if false is 0. I say enter and I close the bracket. And I need this formula copied down, double click. Yes, now it's working. Okay, I must have made some syntax errors earlier. Okay, now here the moment it is 50, because moment you are above 50, you are a senior. Up to 50, you are classified as an adult. Okay, so all the way from 50 down till 18. So that's the age group. So 18 and below is children, classified as children. So yeah, so basically 19 and above, so 18 and below is classified as children. Okay, so here the moment this transition happens is children 1, this is 0. Okay, fine. I'll hover over this formula once again. So AND condition, it's testing for two conditions, criteria. That is if F3 is greater than G1, and second condition is If f3 is less than 50, both these conditions or criteria are satisfied, you give the value 1, else you get 0. Okay. So now we have this data also. We have classified into children, adults, and seniors. Now we also want a gender classification. So let's look at that as well now. Insert. I hope everybody is following. I hope nobody's getting left behind. Right? Please let me know in case anybody is having issue with any of these things. Okay. Okay. Moving forward. All right. So now insert one more, and I'm saying male. This is simple. Control C, Control V, Control C, Control V. So I'm just doing this so that there is no matching error. Okay. So if this is equal to this and lock it, F4, then 1, hence 0. Okay, so male, female. Okay, similarly, this is the opposite here. Is equal to if this is equal to this, then 1, else 0. Okay, I will lock it. L1 has to be locked. Okay. F4. Fine. Okay, so survived is given as it is. Male, female, survived. Okay, so we have the requisite data now. So I'm going to copy this, duplicate this tab. So I'm saying move or copy, create a copy, move to end, and I say OK. So I have, I'll rename it as analysis. Okay, right. So now I don't need these anymore. Okay, but there is an issue. Okay, so if I simply delete it, it will create problems for me. Okay, so what I'll do is I will select the whole thing, Control C, and I'll say Control V, and I'll say values. Okay, so my data has got considerably cleaned up. I only want the values. I don't need the passenger names anymore. So I delete that. I have this information: passenger class, first class, second class, third class, age, children, seniors. I don't need this information. I have captured this. Delete that. Okay, I don't need this age information anymore. Delete that. Okay, I have first class, second class, third class, children, adults, seniors, male, female, survived. Okay, now let me just run a quick check to see if the data is sort of, check for data integrity. Let me look for, okay, now I also don't need the first column, first row anymore. I'm deleting that also. Okay, now I'm going to make name ranges out of this. Control Shift right, Control Shift down, formulas, create from selection, top row. Okay, I have replaced existing definition of survived. Yes. Okay, so we have the name ranges now. Right, okay. Now, let me again use another Excel form, that is come to use in formula, paste names, paste list. I have all the things here. I delete this. Okay. Fine. You have adults, children, male, female, but I want it in this order, correct? First, I hope. Wait. I hope you know what I have done right now. Okay, because we have taken extensive class on these things. So basically, what I've done is I have created a name range. Then I have simply pasted the name ranges as a paste list. So I have all the names of all my classifications here. Okay, so essentially I have. Okay, so let me now check how many adults are there. This is equal to. Wait, before I do that, I need to put these things together. Adults, children, and seniors, because this is alphabetically arranged. So we have seniors should go here, adult, children, seniors. Then we have first class, second class, third class. So male, female comes here. First class, second class is here. Passenger class is not required. For second class, third class is here. Then I have male, female data here. And then whether survived or not. Okay, fine. So let's look at this. Let's count number of adults is equal to count of count of, I'm invoking the name range adults, tab count if that value is 1. I 60 adults. I can simply pull down the formula, and there is a problem. Okay, can anybody suggest a smarter way?
So sum.
So we can use relative referencing in the end column.
So we can use sum. Yes,
No. See, I'm trying to determine how many adults there are. Okay.
Yes, a sum of adults means now it will count as 1111.
No. I'm just saying. See, I just okay. Let me help you. Okay. Essentially, I have used the I've used the name range here, right? So I can use the name range. Okay, I will use what is called as an indirect function. Okay, instead of writing adults here, I will basically use the indirect function, which is indirect, and I'll refer to this cell adults here and close the bracket. Wait, I don't have an issue. I just want this S to be deleted and enter. I just have to drag the formula down. So what has happened is the indirect function is referring to adults here, and adults is also the name of a name range. So the counter is actually looking for the name range called adults, and it's looking for counting all the values, which is 1. Okay, if you look at the formula here, the same thing, count of is looking for indirect. Indirect is actually referring. Indirect M3 means it will pick up the value from children, that is M3, which is the value stored in, the value of children is stored in the cell M3, and it will look for that name range, and then use the counter function. So count of the number of ones in the name range called children. That's what it is doing. Okay, so one click and we've got all of them.
Sir, sum plus indirect would even work. Sum plus indirect.
Yeah, sum plus indirect will also work. Sum will also work. Okay, so count of this thing or sum of. Okay, but dragging down you need the indirect. That's all I was trying to say. Yes, sum of also for sure. Now I need to see what is the total number of passengers. Okay, total passengers. Let's see how many are there. So let me remove the formula. For that I can just count P class. Oh, count A. count A, tab. Okay, so the total number of passengers is 756. Okay, so total number of passengers is 756, and now we also need to check that adult children plus seniors would count to 756. Let's try that. So all the passengers, that is this plus this plus this should be 756. Okay, that is just checking for data integrity, making sure that formulas are right. So total number of passengers is 756. That is the total number of children, adults, and seniors. Then first class, second class, third class. That should also add up to this number. That is sum these three. 756. Okay. And then the male, female should also add up to that number. It's equal to this plus this. Okay, so our data is absolutely fine. So the formula we applied to sort of classify this into all different buckets, all of that is fine. Okay, so we'll move to the next stage. Anybody uncomfortable so far? If you are all comfortable, please give me a thumbs up with whatever we did till now. We've just cleaned up the data. Yes, okay. Other people. Kiran, Shivam, Aditya, still struggling? Okay, Shivam.
I'm able to follow it. I'm fine.
Not able to?
I'm able to follow it.
You're able to. Okay, fine. How about Om, Satyam, Srivatsam?
Yes, sir, I'm fine.
Okay.
I'm fine, sir.
Yeah. Satyam and Amitav is okay. Amitav, I'm happy to see you because you've mailed me a couple of times saying that your classes were not convenient. Are you there, Amitav?
Yeah, yes, sir. Can you hear me, sir?
Yeah, I can. So is it okay? You're following, right? You missed out.
Yeah, I can follow, sir.
Great. Okay. Yeah, fine. Okay, let's move on then. All right. So this is what we have. Now we need to find out, look for support, left, and confidence. Support, confidence, and left. Okay. So essentially, what is the question now asking us? It is asking us, using rules of association, support, confidence, left, determine which cohort of passengers across age group, class traveled in, and gender has the greatest chance of survival. Okay. So we need to see. So our antecedent is going to be this. Control C. Let's say Control V. Oh no. Control C. Control V. And I don't want I just want the values. Don't want the formatting. This is my antecedent. And the consequent is that the person has survived. Control C, Control V. Okay. So this is the association we are trying to check. So the first thing is we are trying to determine the probability. Okay, so this is the adults, children. Okay, let us find the individual probabilities. Probability of adult is that will be this divided by total number of passengers. Log that F4 and drag it down. And okay. So these are individual probabilities of the different cohorts. Now, antecedent, consequent, consequent. Okay, now I'm interested in the joint probability, or what is called support. Support is number of times adults and survived have occurred together. Okay, let us look for that. So let us find the number of times they have occurred. Let's look for the count. That is count F. That is so let's say our name range, adults, fits 1. And the second criteria is survived and criteria is again 1. Okay, so essentially what I'm trying to do is count the number of instances where it is adult, I mean the passenger is an adult and the passenger is survived. Okay, if both these criteria are satisfied, it counts, and we have 215 such values. Okay, now we can of course make this formula a little easier by invoking the indirect formula, and so that then we can drag down the whole formula. So instead of calling adults as in calling the name range here, we can use the indirect formula, and let's say indirect, and then I use cell reference here, L15, and I need to get rid of adults from here. And I can, because survived is common for everything, I don't have to bother with changing that. I can pull it down. Okay, so I'm trying to calculate support, that is the number of times both these things have occurred together. That is number of times adults have survived, number of times children have survived, seniors have survived, so on and so on. Number of times people in first class, second class, third class have survived, males, females. This is what we have tried to do. This is the count of number of times these people have survived. And of course, we can determine the probability. So this is a support. So the probability would be the number of times these two have occurred divided by the total number of times, I mean the total number of passengers, which is 756, which I'm picking from here, and I'm locking that. Writing it down. Okay, so this is the first thing we have to calculate, which is support. That is joint probability of occurrence of each of these. That is of the antecedent and the consequent. Right. So let's. I'm assuming you all are comfortable. Any issues, please raise it now. Okay, it's just how many times they have come together and then divide by the number of instances, and that is your support. Okay, now let's look for the confidence. Okay, confidence is nothing but the number of times these two have occurred. Okay, so basically what does it mean? So if you know that the person has survived, what is the probability that he is an adult? or if you know that the person has survived, what is the probability that he is traveled in first class? All right. So that is given by the joint probability divided by the probability of survived, which is, this is the joint probability divided by the probability that he survived. Probability that he survived is here. I'm picking it from here and I'm locking it. I'm drawing it down. Okay, so there is another way of finding this confidence, which is by actually counting the number of times. Okay, so number of times these two have happened, that is this divided by number of times people have survived, which is 313. And I again lock it. Pull it down. Pretty much you get the same figures. Whatever works for you. I mean, if you're more comfortable with probability concepts, maybe that, or if you're more comfortable with count. So anyway, you get the same results. Okay. So we have support and confidence. Now, when we look at this, which has got the highest support? I mean, which cohort has got the highest support? So we check here. Of course, the highest support is for females, it's 0.29, which means if you're a female, the greatest chance you would have survived. The fact that they have survived and they're a female, the probability is 0.29. The fact that they're adults and they have survived, the probability is 0.28. However, if you have seniors and you have survived, the probability is very low, 0.04. The probability that you are a child, children and survived is 0.09. So you can already see some sort of a pattern emerging here. But when you look at the numbers about confidence, so if you know that the person has survived, what is the probability that it is a adult? Quite high, 0.69 here. And if it's a female, again, it is showing very high value, 0.69, which means if you know that the person has survived, what is the probability? It's a female, it's 0.69. If you know the person has survived, what is the probability? It is an adult, 0.69. If you know the person has survived, what is the probability? It's a senior, it's 0.09. 9% of only the 9% of survivors happen to be seniors. Again, 31% of survivors happen to be males, 25% of the survivors happen to be have traveled in third class, and so on and so forth. Okay. Now let's look at the value of lift. Okay. So value of lift is nothing but the confidence divided by the probability of adults, which I pick from here. Okay, pretty high, but we are looking for a value above 1. So I don't have to lock anything because I can simply drag this formula down. Okay, so if you look at this, it is dividing 0.69 with 0.74, which is the value for adults. This formula, it's picking down 0.09, dividing it by seniors, 0.09, and so on and so forth. So here we're looking for lift value greater than 1. So here we 1.32, which is for children, 1 for seniors, 1.48 for first class, 1.09 for second class, 1.8 for females. So the lowest value are for third class for males, 0.49, third class 0.59, and 0.97. So the highest value, of course, is for 1.81, which means compared to the average person who traveled in the ship, if you are a female, there is a the highest probability that you would have survived. The highest value, that is 1.81. So your probability of survival is highest if you were a female traveling in the ship. The next high value is 1.48. That is, if you are traveling in the first class, your chance of surviving than the average person is 1.4 times more. Okay. Next value of significance is 1.32. If you are a child, your probability of having survived in the ship is 1.32 more than the average person who traveled on the ship. Okay. So is that okay? I don't know. I've just been doing all the calculations. So I hope people have been following. Right? Please let me know the issues. Yeah. Okay. So this is the interpretation. Now here right now what we did is we took only one characteristic. That is just whether the person belonged to a particular age group or whether they travel in a particular, let's say, class, passenger class, or they belong to a certain gender. Now, we can now look at the support here and eliminate those groups which have low support. Okay, so typically we could eliminate groups which have, let's say, less than 10% of probability of happening. Say, so if you look at our data here, you notice that, say, adolescents survived very high probability, 0.28. Children, however, it's less than 10. Seniors is also less than 10. And all the other category, that is first class, second class, third class, male, female, all of them cross a threshold, support level of, let's say, 10%. So let's make the next set of items based on that. Okay, so essentially we will eliminate seniors and children, and then we will move forward. Okay, so let's say we have adults. Okay, we will just take this Control C, Control V. We don't want children and seniors because they have low support, that is less than 10. So we don't need children, we need seniors. Okay, so now let's look at adults. Okay, let's put it this way. Male, female. Okay, let's look at like first class, second class, third class. And let's look at males. Control X, elsewhere. Let's look at this. Control C, Control V, Control C, Control V. So this is now going to be a revised antecedent. Antecedent. And a consequent is survived. Okay, we've not got all of them. So first class male, second class male, third class male, first class, second class, third class. Then we have adults also here, right? Okay. So Control C, Control V, and then we need male, female. Okay. Okay, so I hope this is self-explanatory. I hope you've understood what I have done. Okay, I've just increased the item set. I have removed all the items which have got low level of support. So in let's say typical shopping basket, instance, what you would say is it's possible that there are some really high value transactions. Let's say I don't know, caviar plus maybe with Scotch whiskey or whatever. But if the number of times these two things are bought is very low, out of 10,000 transactions, if only 20 people have bought these things together, I'm not very interested in that. Even though it's high yielding, let's say scotch and caviar are expensive items, but the fact that they only purchased 20 times out of 10,000, I would lose interest. I'm more interested in things which are which are bought together many number of times. So the overall number of instances in the entire 10,000. So if something exceeds, let's say 1,500, I am happy. So if something is less than 100, I'm not very interested. Correct? So if the support is low, which means if the joint probability of those instances happening are very low, then I would eliminate them from my iterative process. Correct? So this is what I have done. Essentially, I've removed children and seniors because a child surviving and a senior surviving, we've noticed the probability, that is the baseline probability, be very low, less than 10. So I removed it. So I fixed at 10%. We could, of course, take 15%, 20%, depending upon the data set. But because there's a really small number of classifications, so I just eliminated the two minimum. Okay. After that, I have redefined the antecedent in terms of two of them together, as in the combination. So all the combination of the remaining things. So typically it is NC2, that is remaining classification, which is let's say one. Yeah. So yeah, I mean, I hope it's self-explanatory. That is 6C2. I've taken combination of all the remaining things. Okay, and I've taken that as an antecedent, and the consequence is, of course, survival. All right, fine. Now let us go forward and see what are the values of support, confidence, and lift. Okay, so Control C, Control V. So what is the probability that it is first class and male count? So again, it is count of first criteria. It should be first class. Okay. So let's say first class, name range, and the criteria is 1. Second criteria is male. Tab. Criteria is again 1. Okay. And support survived. Survived. Sorry. Survived and yeah. Tab. Why is it not picking? Okay. One. Okay, COUNTIF. I should say COUNTIFs. COUNTIFs. Okay, fine. Now it's okay. Fine. So essentially, the number of times these three things are happening simultaneously, that is, the person is starved in first class, is a male, and the person is survived. So that is the support, which is the joint probability, the number of times these three things have occurred. Fine. And I can't drag the formula down because I have not used indirect referencing. So let me do that. So instead of writing first class, let me write indirect and reference that particular cell here. Close the bracket. Again, for male, I will use the indirect formula and reference this particular cell. Close the bracket. And for survived, I would use indirect, refer to this particular cell. I have the value. Now I can drag it down. I had different values. And the probability would be count times the number of survivors. I mean, number of passengers, sorry, not the number of survivors. So what is the number of passengers we have? Total is 756. This value here. And let me lock it, F4, and I have the requisite probability. I drag it down and there we have it. Okay, so for the revised antecedents and consequence, this is a support. Okay, now let us look at confidence. Control C, Control V. So for confidence, I would actually need the standalone, like the probability of first class and male alone. So let us, okay, wait. So what I would do is layer formatting. Okay. So before I come to that, the support stay here. So I want to find the probability of the antecedents. Okay. Antecedents, their count and probability. It's basically the same thing, Control C and Control V, but I don't want survived. So I'll remove the third reference, that is indirect. Okay, so essentially what is counting is counting first class and male. So indirect L26, indirect M26. It's only counting first class and male. Okay, so this is the count of the antecedent. So we are looking only at the antecedent here. That is here. So the antecedent count is this, and probability would be number of times they would occur divided by the number of passengers, which is 736. And I'll lock it. Lock the cell. Add both these formulas now. Okay, randomly verifying. Okay, first class and female. Count as this. Frequency is okay. Probability is this. Okay. So now we have okay, the probability of the antecedent, the count of the antecedent. We have the support. Support is nothing but number of times all three have happened, and probability would be the total number of passengers. Okay. So now we have this support. We need the confidence now. Okay, let us pick. Okay, confidence is
Excuse me, sir. Can you please hover on the cell P26?
B26, is it?
P26. P for parrot.
Is it okay?
Okay.
Yeah, basically it's the count divided by number of people who've traveled. N11 picks up the value here. Total number of people on the ship. 76 and 56 passengers, right? So there were 756 people in the ship, and then out of which 125 happened to be male and they traveled in first class. So the probability would be 125 divided by 756. Is that okay? That is the probability of antecedent. This time our antecedent is two things, first class and male. Is that okay, Aditya?
Yeah, that's fine now. Thank you.
Fine. Any other concerns? Please interrupt me in case there is an issue if you have not understood. Okay, we've spent so much time doing counter sum if this and that and all that. So I'm assuming that you're comfortable by now. Okay. Anyway, right. Right. So now we have the antecedents. We have the support. Now basically confidence would be joint probability. So support is also joint probability. So, okay, this would be this figure, that is joint probability divided by survived, probability of survived. That is here. Lock the cell. And pull it down. And I'll kill some of the decimals. Okay. So essentially what confidence is telling us is, given that the person has survived, what is the probability that the person was a male and he traveled in first class? That is 0.14. For the next number, basically, if it's known that the person has survived, what is the probability that he is a male who traveled in second class? And similarly, for the last value, it is interpretation is, if we know that the person has survived, what is the probability that she is an adult and a female? A person is a female and is an adult. So clearly, again, you can see the support is the highest for women, that is 0.2, which is if it's an adult and a female, there is a great probability that she has survived. And next highest for first class, women who have traveled in first class, there is 0.13. Okay. If you look at confidence again, if it is known that the person has survived, there is a greatest chance she is a female, adult female. And next highest confidence is for second class female. So if it's known that the person has survived, there's a very high probability, that is 24% chance that the person is traveled in second class.
First class female.
No, it's second class female, right? Sorry,
0.3.
there's a 0.31 also. Okay, I'm sorry, I was looking at 0.2. Yeah, sorry. Yeah, I stand corrected. It is actually a female who's traveled in first class. So if you know that the person has survived, there's a greatest chance that she is. There's a 31% chance that she's traveled in first class and is a female. Okay, and then second class slightly lower, 24. Now, conversely, if you know that the person has survived, there's a very low chance, that is less than 7% chance, or rather 7% chance that the person is a male and is traveled in second class. Okay, so that is the interpretation of confidence. Let's look for lift now, because we've seen confidence can sometimes be misleading. So let's also calculate the values of lift, and let's be more sure of our findings here. Okay. So lift is nothing but this value, confidence value, divided by the probability here, the antecedent probability here. And we don't have to lock anything because we will drag it down. And let us kill the decimals. Okay. So you can see now 2.3. If you know that the person has survived, so if it is a female who's traveled in first class, there is 2.3 times, she's likely to have survived 2.3 times more than the average person on the ship. Similarly, if it's a female and she's traveled in second class, there is a 2.13, there's a probability that she's, chances of her survival is 2.13 times more than the average person. Conversely, on the other side, if you are an adult and a male, so there is only like 0.44 chance, like your chances of survival are very less. Okay, so this is the whole idea of market basket analysis. You look at support, confidence, and lift, and you can look at the number of times, the rules of association. Any questions, concerns about the things we discussed? If everything's okay, nobody's got confusions, doubts, or you've not followed anything. This is awfully silent. Okay, let me know, give me a thumbs up if you understood this. At least you may not be able to do it yourself in the first time, but like if you understood whatever I was doing. Okay, fine. Okay, yeah, so that's just about everybody has gotten this. Cyan is not understood. Cyan, what are the issues?
So I have understood.
Okay, Cyan is done. Okay, fine. Monu? Monu's not around? Is it?
Yes, sir. I'm fine with all this.
Fine. Oh, alright. Was it too simple? Please let me know.
Yes, sir, it is understood and simple.
Okay, fine. Okay, all right. Okay. So this is the whole concept of support, confidence, and lift. And I think in first class, well, the first week, somebody was asking about this, particularly about market basket analysis and some questions. I think was it Deepak? It was either Deepak or someone else.
So it was me.
It was Sayan. Yes, Sayan. What was it?
So I forgot. Don't remember.
No, but have you understood it at least now? Because you were asking me, I told you I will take a separate class on market basket analysis towards the end.
So I've understood, sir. Yes.
You
Yes.
play with the concepts, right? Because you were
Yes,
asking
sir, yes.
something in the introductory class. I said I'll take it up later. So I hope you're okay, right?
Yes, sir, definitely.
Fine. So we'll take a 5-minute break and resume then. All right.
Yes, sir.
Okay, fine. So it's
Sure, sir.
so if you come back to our analysis which we did earlier. So if first class and male passenger and fact that he has survived, the probability that his support is 0.06. For the next instance, second class and male, the support is 0.03. Third class males survived, probability 0.04. So none of them is actually meeting the 10% criteria. So we were actually using the 10% criteria earlier, correct? So there you find that only 3 instances wherein the 10% criteria is met. The first is first class female survived. The second is second class female survived. And the third is adults female survived. Okay, so clearly we could use first class, second class female, adult, and then we could have the next set of iterations to check for to find which person had the best chance of survival. Okay, so let's do that, and we will this time only consider these 3. That is support value here 0.2, 0.09, 0.10. Okay, so first class female adult. Okay, it's better to copy the names, otherwise name referencing indirect won't work. Okay, first class, second class, control C, control V, and female, control C, control V, adult, female, first class, second class. Okay, any other combination possible? Correct? Any other possibility, any other combinations possible with these variables? First class female adult, second class female adult. Third class is ruled out, has no support. Adult male is ruled out. All males are ruled out essentially. No, not enough support. Only female, first class, second class, adults. Okay, so these are the only 2 possibilities. Again, so this is the new antecedent. Control C, control V. Okay, this is the consequent. Control C, control V, and okay, let me push it down a little bit. Okay, so let us look for antecedents, counting probability. Control C. Okay, count. All these 3 criteria should be satisfied, which is count if criteria range indirect. This first class should be equal to 1, comma indirect, female, that is M38, equal to 1, and third indirect, okay, and write the formula down. Probability would be this divided by total number of passengers on the ship, which is and lock it F4. So you see that the probability is actually dwindling down quite rapidly. Okay, this is antecedent support. Control C, Control V. Support is essentially the same thing. I'll copy this formula. Control C, Control V. Okay, and I'll try to fix this. Also need to add survived. So counters indirect, survived, comma 1, and probability would be this divided by number of people traveling. Lock it. Okay, let's look for lift now. No, let's look for confidence. Control C, Control V. Confidence is nothing but this divided by consequence. Objective survival, sorry. This, okay, the survival. Probability of survived this. Okay, lock it. Filling the decimals. Okay, look for lift now. Control C, Control V. This is nothing but this divided by this probability. You don't have to lock anything there. Let's drag it down. So now we notice that if you are a first class passenger, if you're a female, and if you're an adult, your chances of survival is 2.3 times more than the average passenger on the ship. And similarly, if you are a second class passenger and if you're a female and if you're an adult, possibility of your survival or probability of your survival is 2.11 times greater than the other people who've traveled along with you, other co-passengers. Okay, you would now notice that your support is actually, for both of them, have gone below 10, and at this point you end the iteration. Now when you have a large market basket this is the iterative process, so that you understand, so like say for instance, there are several number of antecedents and several number of consequence. This is the process that you follow. I hope it's okay. Any concerns? Particularly, let me go back to Sayan again. Sayan, things are okay?
Yes, sir, fine.
Okay.
Do we use different softwares for this?
No, it is possible. I mean, there are of course different. I think even Excel has got the advanced versions of Excel. That is, I think 2019 or 2020 edition. It has a market basket analysis tab itself in some advanced analysis. So we don't have to go through all this. Here, of course, we've had to use all this understanding of probability. And so, see, as with most things, even Excel, there are so many things. You just click 2-3 times, you will get the output. But it's the interpretation which is a problem. And the explanation of lift is actually, it's a little counterintuitive. Correct. So you can just click a button, you will get everything. You will get support, you will get confidence, you will get lift. But how do you interpret it? What does it mean? So that is the issue. And you would have noticed, if you're familiar with other software like SPSS or even Excel, has got so many functions where in one click you get entire descriptive statistics in 3 clicks. But it's just how to interpret it, what does it mean, what do each of those things stand for, and all of those kinds of things, which needs a little bit more understanding of statistics or whatever, analytics or whichever way you get it. Okay, fine.
Yes, sir.
Let's move on.